All right, I think we have to start now. Welcome to today's Luohan Webinar. So my name is Xijie. I'm the moderator for today's event. So today we're very happy to have Niels from IMF to talk about a very interesting topic, which is the price of intelligence. So Dr. Lehr, Niels Lehr is a researcher and economist at the IMF, specializing in economic growth, innovation, entrepreneurship, and technology adoption. His research combined quantitative modeling with like a rigorous empirical method to illustrate the mechanism driving innovation, entrepreneurship, and technological choices on a macro level. So without further ado, I will pass the floor to Niels. So Niels, you're going to have about 1 hour. Thanks.
Thank you so much for the kind introduction. Very much looking forward to this. Thank you so much for inviting me here to tell you a little bit about my paper with Pasquale Restrepo, The Price of Intelligence, how should socially minded firms price and deploy AI. As was already said, I'm currently an employee of the IMF, and so as that, I have kind of to give you the standard disclaimer that the views expressed here are, of course, only mine and Pasquale's, and should not be attributed to the IMF, its executive board, or its management. So this project was really motivated by a simple observation that many of the AI firms that were leading when we started to look at this topic proclaimed in their mission statements to optimize for something that was broader than just like firm value. So here, for example, you can see the OpenAI mission statement saying that they want to benefit all of humanity by helping to create broadly distributed benefits. And similarly, in Anthropic's mission statement, you can read that they want to maximize positive outcomes for humanity in the long run. Now, these kind of mission statements stand a little bit in contrast to what we typically kind of in economics think firms are doing, or like what kind of going back to Milton Friedman has been the idea that, like, you know, his big idea was the social responsibility of businesses to increase its profit. So something that is very profit oriented versus these mission statements that were more kind of towards the benefit of humanity. And so essentially what we're going to try to look at in this paper, what we're trying to explore here is, suppose that you have a firm where you care about more than just profits and you're an AI company, what should you do? And so the two premises that are kind of foundational to this paper is going to be the idea that suppose you are someone who runs an AI firm, you value shareholders, of course, but you also potentially value broader social welfare or potential labor market stability. And you'll see later what we exactly mean with labor market stability. So you are kind of in charge here, but then you develop also this AI technology that is capable of substituting for some human skills at a fraction of the cost. So you have this very powerful technology. And then the question becomes, given these two premises, what should you do? And essentially, our answer is going to be, we're going to show that in our framework, you end up with a kind of modified learner's rule, where the margin that you charge, so the price minus marginal cost over the price, should be equal to a modification factor M over the price elasticity. And so, of course, we know that the kind of standard baseline optimization model would tell you it's 1 over the price elasticity. But if you have these broader social concerns, you have a modification here. And that's going to be essentially the punchline from a theoretical point of view. And then later on, I'm gonna show you the formulas, and then I'm gonna try to illustrate kind of what this modification could do in practice, looking at AI deployment, at least for the US. So that's going to be a little bit the outline. And at any moment in time, if you have any questions, please feel free to jump in. Now, at this point, let's just dive into the paper and starting off with the economic environment of the model. So we're going to index time t. It's going to be continuous time. There's going to be a set of commodities in this economy that we index by J. Most importantly, J equal to 0 is going to be our numeraire good. And you'll see in a second why that's convenient. And then these goods, in principle, they're going to be produced from some kind of tasks S. Here you can think of like the standard way of task, economic reasoning, writing, welding, these kind of activities that then ultimately make goods. The economy is going to be populated by two types of households. There's going to be shareholders and there's going to be workers. Shareholders, there's going to be a mass epsilon of them. Those people will own the firm and they will supply no labor input. So those are pure capitalists in our framework here. Their utility is going to be very simple. They're only going to consume the numeraire good and they're going to maximize the present discounted value of that consumption, subject to a standard budget constraint, where again, the important part here is that their only income is coming from profits. The second type of workers here is going to be, of households is going to be the workers. There's going to be different type of workers. We're going to index them by age, and each of these type of households is going to supply a vector of skills to the market. So these skill sets can be potentially different across households. And you can think that, ultimately we're going to go in the direction of differentiating households by income percentiles. And so you can think that some types of households are going to be more exposed to, let's say, the welding skills, others going to be more exposed to the economic reasoning skills. And the way we're going to capture this is by this NHST. These households, they are then going to, maximize utility again, where we're going to assume that their utility is going to be quasi-linear. So they still are linear in the numeraire good, C0, the same way as the shareholders, but they also are going to have some utilities from other consumption goods here, and there's going to be curvature. Otherwise, they face a standard budget constraint where they get income from working. So each task is going to have a wage. The household is going to supply the task and going to earn the wage for it. And then they can kind of spend that income on consumption goods. Now, one thing that I want to briefly highlight here is that the way we set these things up here is that we have this very clear separation between shareholders and workers. It's going to be useful for us because it's going to give us this idea that what firms are maximizing, in a sense, when firms are maximizing only profits, or they don't care about the workers. Where, of course, you could think if these workers would also hold shares of the firm, then maybe the firm should also care about the workers. We're going to kind of kill that by just assuming that capitalists are who own the firm are entirely separate from workers. That's the household side of the economy. How does technology work in this economy? We're going to start off a little bit more abstract, and later on I'm going to give you more direct formulas in our application. So there's going to be a commodity production function that's going to be constant returns to scale in the vector of commodities and task inputs. The tasks themselves can be either completed by human workers or in some cases by AI. So for the tasks that cannot be completed by AI yet, the total task supply, LST, is just going to be the integral over all of the household types of the supply from that particular household type in that task, NHST. For tasks that have been automated where AI can do something, we're going to have the same supply from the worker side, but now we can also use AI-generated input to complete that task. So QST here is the amount of AI-supplied input. That AI-supplied income doesn't come for free. It's going to cost some compute. So psi ST is going to be the amount of compute units per unit of QST that you need to produce the AI-generated input. And then we're going to call the total of these expenditure on AI-generated input compute XT. And that's going to be produced again one for one from the numeraire good. And so in a sense, I think this is a very standard automation type of framework. Now we're going to think about this here in the context of AI. Um, the commodity constraints, the market clearing constraints are here. The last two equations here, where the total compute, as I just said, is just the marginal cost of producing compute times the total amount of compute. And then, of course, for commodities, it's going to be the case that for the numeraire goods, the total production of the numeraire good has to be at least as large as the consumption from shareholders, consumption from workers, and the amount of compute that we use. And then for all other goods, the production has to be at least as large as the total consumption coming from these workers. What is our notion of how we solve this model then? Well, we're going to assume that there's an AI firm. So there's a single AI firm. We're thinking about this as a world where there's essentially an AI monopolist that chooses a feasible production plan. And as a monopolist is going to anticipate all the effects that its choices have on prices and quantities. All other markets are going to assume to be fully competitive. So those are then going to determine equilibrium prices for the labor inputs and the prices for the commodities. And then the profits that the AI firm is going to earn is just going to be the price minus the marginal cost times the amount of AI input that is supplied across all the different tasks. So far, so good. Now, the part where I think we're going to be a little bit non-standard, and that's kind of the thing that we really want to think about, is coming next in terms of the objective of the AI firm. So we're going to assume that the AI firm cares about potential three things. So first of all, it's the present discounted value of profits. That's kind of how we typically write down kind of profit firm optimization problems. But then we're also going to allow that the firm potentially cares about broader societal benefits in terms of utilities. And then finally, they might also care about minimizing labor market disruptions. So the second term, as you can see here, the mu h is going to be welfare weights that are applied to individual households. And UH is just the present discounted value of it's the kind of utility, long run utility of the household H. And so mu h then gives you a weighted average of these utilities across workers in this case only, right? And so you can think of this as basically capturing potentially that the firm cares about societal welfare instead of just profits. The last term here is going to be, I think, is a little bit more non-standard, is we're going to assume that the firm potentially cares about minimizing labor market disruption in terms of minimizing wage losses. So what this firm essentially penalizes here is low wages. So WHT is the wage at any moment in time. And you can see that the last term is kind of going to be smaller if these wages are all low. And what this captures is the idea that the firm might dislike that if it supplies a lot of AI, it's going to push down the price for kind of the wages in the tasks that it competes with against labor. And it might dislike that because of kind of the disruption cost to workers. And the important part here is the idea here is that potentially we care about just the wage impact instead of the ultimate utility impact. So that's potentially slightly different. You can think of it as like a firm that potentially cares about, let's say, the optics of its behavior a little bit more than the actual utility impact. Now, with that, we can kind of start thinking about how does the optimum... Yes.
Niels, can you go back one slide? So
Yeah.
here, the labor market disruption seems to be a lower wage, right? But in
Yes.
reality, the concern is that there are going to be massive unemployment. But here in your model, it seems like it's fully employed, right? So is that isomorphic, this kind of assumption?
Yeah, no, you're absolutely right. So in our model, we are not going to have unemployment. We're going to assume that at any moment in time, there's going to be full employment. But of course, workers can still be hurt from AI. And exactly as you already pointed out, like the way they're going to be hurt by AI is by earning lower wages. And so I guess the way I would think about this is something like reducing the expected net present value. While of course you can also think that in practice we might care a lot about kind of the unemployment impact as kind of a separate category than just like reducing expected income. I think the unemployment angle is also very interesting. Here we're kind of simplifying our kind of simplifying the task for us a little bit by just focusing on the wage impact. But on some level, I think we believe that the wage impact is kind of very important in and of itself. But point well taken that like unemployment might be an additional angle here. So how do we actually like? How does have the firm solve this? Well, the way we're going to ultimately derive our main formula is going to rely on a variational argument. That's something that we also used in the optimal gradualism paper, and goes back to Costino and Werning's paper. So the idea here is going to be that suppose the firm considers a little deviation from its production plan, where the little deltas here are supposed to be kind of telling you that the small deviations of the production plan in terms of the individual AI input quantities, and then of course the total compute. And we also throughout are going to assume that all workers are consuming at least some unit of the numeraire good. And of course, what we want to kind of exploit here is that like all the changes in household income are going to be mapped to the numeraire and not to the other goods. That's where kind of the quasi-linearity kind of makes our life a little bit easier here. So given this little change here, what is going to be the effect on households and on profits? Well, on profits, the little change is going to be kind of a standard profit from profit maximization. We know it's going to be, well, the total, the quantities times the induced change in the price that's coming from the variation in quantities, plus the margin, so the current price minus the marginal cost times the change in quantities. Aggregate efficiency is going to look quite similar. It's going to be, again, about kind of the difference between the price minus the marginal cost times the change in quantities. Now, in addition, we have these distributional concerns here, and the way they're going to come in here is coming from the potential change in the wages that is induced by this change, where the change in wages, this delta WST, the induced by the actions of the AI firm, is going to be mapping into these distributional concern terms, both through the amount of tasks supplied by the workers, so this NHST, and through the relative welfare weight GH. So the way to think about it, GH is kind of, it's a normalized version of just the muse, which is such that it aggregates up to 0. So this is a pure relative statement about preferences. So large GH says that for the particular group H, we care about them more than about the average household, and vice versa. And then finally, we have the stability concern, which look very similar, but the important difference here is that instead of weighing these stability concerns by GH, we are now weighing the same term, but by the initial wage, which is capturing the idea that by the setup, we will like wage changes less if they are, so we will like wage declines less if they hit workers that have already low wages for a given amount of change. And so then, of course, what has to be in equilibrium? In equilibrium, it has to be that there's no profitable change around the values that the firm chooses, such that the sum of these 4 terms weighed appropriately has to be equal to 0. So that's kind of the standard first order condition argument, where at the margin, you must be indifferent between the plan around the optimum. Now, what does this give us? It ends up giving us something that's very neat and simple. Here for the optimal pricing formula that I'm going to show you, I'm going to focus on the case where commodities are produced with specific task, which is going to make our life a little bit more easy. And particularly, it's going to give us independent demand curves for each task, such that the demand elasticity for each task is kind of independent of other tasks allocation. And so with the setup, then we're going to have that for a task that is in the set of automated tasks, big A, the equilibrium prices and quantities are going to satisfy this modified learner's rule that I mentioned in the introduction. So the learner index here, the price minus marginal cost over price, is going to take, this form, where you can see here on the right-hand side, maybe I should highlight that first. On the right-hand side is 1 over the demand elasticity, and then we have a, let's say, relative 4 terms multiplying this elasticity. Going step by step, the first term, the 1 that you can see here, that's just the standard profit maximization, where we know from kind of micro classes that kind of the standard profit maximization condition is that the learner index is equal to 1 over the demand elasticity. That's the kind of the standard markup formula. But here, because the firm cares potentially about additional things, we have additional terms. In particular, the next term, the minus mu here, is going to account for the utilitarian considerations. So you can already see that if this mu is equal to 1, it's going to cancel out the profit consideration. And so in that case, the firm is so utilitarian that in absence of the third and the fourth term, it would equalize price to marginal cost. So it would choose the efficient allocation in that sense. Now, the third term here is going to capture the distributional concerns. And so you can see that the third term essentially is this product of this GH, which again is the relative societal Pareto weights on the utilities of household H, times the task supply of that particular household type. And so it has this covariance form, where this term is going to be positive if the particular task S, if the households that are most exposed to the task S in terms of supplying units of this task S to the market, if they're also going to be on average kind of have a higher welfare weight than everyone else. So just to say something a little bit more intuitive, suppose that we care more about poor households than about rich households. This term is going to be positive if AI technology is disproportionately focused on poor households, because in that case, we want to kind of help them. And so we want to increase the learner index so we want to increase the price to shield them from the technology impact. Now, the last term here, what we call the stability concerns, works in the same way. You can see that here, the term looks essentially the same as the third term, but now we are weighing households not by the relative utility, Pareto weight, but actually by the inverse of their initial wage. So that's going to imply that in general, this is going to imply a higher learner index, so a higher price or higher markup for technologies that are particularly hitting low-income households stronger. Now, this formula has a couple of additional insights that I want to briefly highlight. One of them I already mentioned is that if we forget about the third and the fourth term for a second, just utilitarianism is going to push us towards marginal cost pricing, where if mu is equal to 1, then 1 minus mu is equal to 0. And so the learner index being equal to 0 implies marginal cost pricing, because the price WST has to be equal to marginal cost mu-st for that to be in equilibrium. The distributional concern term, again, is going to be telling us to curb quantities or charge higher prices if the households that are more exposed to the AI technology here, or to the AI technology for the particular task, are going to be also receiving higher relative welfare weights. Stability concerns work differently, but here maybe one thing to highlight is that GH can be in theory negative, while of course wages are always positive. And so the stability concerns term is in a sense is going to be potentially more positive than the pure distributional term, coming from the fact again, just mathematically, that the wages are positive. Two other things to highlight here, thinking about dynamics and the productivity of AI. The NHST, so that's the task supply by household H at time T for the particular task that we're thinking about here. Of course, we can think that that is not a constant over time. In particular, we might think that if there's a task that is particularly exposed to AI, maybe workers kind of slowly retrain over time and move out of this task. Now, what this is going to do is it's going to reduce the size of the third and fourth term. And since they're positive, it's going to reduce, well, to the degree that they're positive, it's going to reduce the absolute value of this modification factor. And so as a result, it's going to push us towards higher prices. It's going to reduce over time. So it's going to reduce the total M. It's going to push us towards lower prices. So lower learner index. So in that sense, what the stability concerns kind of call for is potentially a slow rollout, where initially, because of these concerns, we want to not price as aggressively, but over time, because workers are adapting over time, we get ever more aggressive in our pricing strategy. Because we're less concerned in a way about the welfare impacts. And now the final thing to point out here is that in both the third and fourth term, QST is in the denominator. And so what this mechanically implies is that we care less about these stability concerns or the distributional concerns if the AI technology is really good. So if QST is really large, so we have a really good technology, we care less about the distributional impact. And so I think the intuition for that is that if the AI technology is fantastic, then we definitely want to exploit it. But if the AI technology is not as good, then maybe there's other concerns that we also want to kind of take into account more, because the baseline benefit of the technology is just less. Now, in a second, I'm going to try to kind of show you exactly these mechanics in some diagrams. But to do that, I'm going to do two further simplifications along the way. In particular, I'm going to make a functional form assumption about the quasi-linear part of the function. So I'm going to assume a power function here for the utility of the goods that are not the numeraire good. And then I'm going to assume that the households are going to shift away from the disrupted markets at a constant rate alpha. And so that's going to allow us to potentially consider the kind of impact or the optimal pricing rules across time. Now, what this is going to give us, these two things are going to then allow us to perfectly describe the equilibrium prices and quantity for each task S that is automated or like potentially subject to AI through two equations. The first equation is the supply equation. So that's just the learner's rule that I just showed you, or we just plugged in kind of the value here for the household shifting away over time. Same formula. The only thing that like here you can see on the right-hand side here is now the demand elasticity is a function over time, because from the perspective of the firm, in Cournot competition, it's going to be the case that the firm, in a sense, has more market power if there's fewer workers that are currently in the also supplying the task, because these workers are implicitly competition from the perspective of the firm. And then the demand equation is just saying that pins down kind of from the household side what the price has to be. Now, With these, I can then walk you briefly through kind of how these dynamics could be playing out in a kind of diagram way. So here, first, I'm going to show you the demand curve downward sloping. On the y-axis is the AI price. On the x-axis is the AI quantity. Now, pure profit maximization gives us the baseline learner rule. So that's what I'm plotting you here. The kind of supply equation is the light blue one, which is curved because of the AI quantity determines the demand elasticity that the firm is facing. And so you can see that, well, you're going to end up with some kind of markup above marginal cost and at the intersection as per usual. Now, what about the utilitarian firm? So the utilitarian firm here again only has this additional factor where it cares about aggregate efficiency. So it's this minus mu term. And so, of course, what is the minus mu term is going to do? Well, the demand curve is still the same, but now the supply curve is going to be downward shifted or curved downward because the firm cares about the total aggregate output, or like cares about aggregate efficiency. And so what is this going to lead to? Well, a lower markup, higher quantities, exactly as we would expect. What about the welfarist firm? So the welfarist firm also has the utilitarian aspect, but now potentially cares also about the distributional implication here. And so here, what I'm showing you as an example is an example where there's a positive correlation between the relative utility weight and the task supply. So here, that's the case where we potentially care more about the workers that are particularly exposed here to this AI. And so you can see that this term, depending on strength, can even make the supply curve downward sloping, at least locally. And this is going to imply, in general, that the optimal quantity is going to be smaller than the utilitarian firm, and vice versa, the markup is going to be higher. And then finally, what if we have a conservative firm? So a conservative firm doesn't care about the utilitarian aspect here, but might care about the labor market disruption. And so this is going to look somewhat similar like a welfarist firm, but with a kind of a stronger impact because we don't have any consideration here for aggregate efficiency, and vice versa. The term tends to be larger because all wages are positive. And so this is then generally going to imply that it's going to be for sure the case that the conservative firm is going to be pricing at a higher price than the profit maximizing firm. Because of this this positive term here. And so that kind of goes to show that depending on what is the preference of the firm, actually we might have very different implication for like how these AI firms should be pricing their AI. If it's a firm that cares mostly about the labor market disruption, then maybe actually it should kind of charge a higher price, roll out the technology slower. Vice versa, if the firm is very utilitarian only, then maybe actually should charge a lower price to maximize the total impact of the AI technology. Now, at this point, I want to switch over a little bit and try to explore this in a more with an illustration. Where we're going to try to use some US data to kind of inform us about how these forces could be playing out in practice when we're trying to actually plug in some numbers that we think are like somewhat reasonable. And so the way we're going to do this is that we're going to illustrate deployment paths for each of the 500 occupations in the US. Where essentially the question that we're going to ask is, suppose there's an AI technology that can displace the tasks that are important for this particular occupation, but only of this particular occupation. how should the AI firm, the AI monopolist, how should they price this technology, given kind of the rest of the, I'm given the things that I'm going to tell you in a second. So households here, we're going to assume that they are determined by income percentiles. So we're going to have 100 different household types, and we're going to measure their exposure to different occupations coming from the fact that different household types in the census data are differentially exposed to different occupations. So quite intuitively, workers, respondents on the kind of higher income side tend to be more exposed vice versa. Economists tend to come from higher income percentiles than janitors. So that's going to be kind of the idea. And so their household exposure to a particular occupation is then coming from exactly this kind of variation. We're going to assume for each of the occupations, we're going to assume demand elasticity of 3, and then consider the scenario where the AI technology leads to cost savings of 50%. So the marginal cost that we're going to assume here is going to be half of the task wage pre-AI. And so in a sense, I think the way we think about this is that this is a fairly good AI. And so then the question is this is a fairly good AI. And then we're going to set the value for the transition rate of households out of tasks that are AI exposed at 4% per year, which is kind of going back to some of our work in optimal gradualism, where we link this rate to the path-through of demand shocks to wages. And then finally, in this exposition, we're going to set the relative weight on the utilitarian part to 0.5. So mu is equal to 0.5. And then similar for the conservative firm, we're also going to set the lambda equal to 0.5 as kind of an illustration of a firm that basically cares half as much about kind of the welfare impact as about profits. That's kind of the way to think about this. And then finally, the question is, of course, how should we think about these welfare weights? And we're going to take them from Lockwood and Weinzel, as I'm going to show you in a second. So Lockwood and Weinzel, they have this very cool idea of taking the US tax code and kind of assuming that the US tax code is kind of the result of an optimization problem on part of the politician. And so then, given this assumption, you can essentially back out what are the implicit welfare weights that the politicians are putting on each type of household across the income distribution. And so we're going to take exactly kind of that inversion that they're taking to then calibrate our welfare weights, GH, sorry. And so that's what I'm plotting you here. And so you can see that GH, so the relative welfare weight, is going to be larger on poorer households and much lower on high income households. So this is a relative weight. That's why we have negative numbers here. It's of course the case. We don't think here that the kind of US politicians care negatively about the welfare of high income households. It's just they care less than about them than for the average household. And maybe just one thing to flag already. So when we do that, one thing to highlight here is that actually the average occupational weight across the occupational wage percentiles is not quite as there's not quite as much variance in them as in the underlying household percentiles, which is coming from the fact that households, occupations and households don't map one for one. And so as a result, even the lowest income percentage of households are going to have a wide exposure across occupations. And so that's kind of going to essentially make the policy a little bit less targeted, and that's going to matter for what I'm going to show you in a second. Now, what do we actually get when we then plug things into our formulas here? So what I'm showing you here on the left-hand side is the optimal markup at on impact. So the timing here, again, the only thing that changed with time is the amount of workers that are still in the particular task. And so this is on impact. This is when all the workers are still kind of in their initial allocation. And let me kind of go through this kind of piece by piece. So first of all, you can see here is, and on the x-axis is the occupational wage percentile. So first of all, you can see for the profit maximizer, the optimal markup is flat. It's completely the same for all wage percentiles, which is by construction because we assume that the productivity gain is the same in percent. And so that's going to imply that the demand elasticity that these firms are going to face is going to be the same for each of these occupations. So the optimal markup is going to be here, that's the black line, same for all occupations across the occupational wage percentiles. What about the utilitarian firm? Again, the utilitarian firm only adds this concern for aggregate efficiency. And so as a result, the optimal markup drops. And so this is kind of the orange line that you can see here at the bottom of the figure. Now, if we also add the distributional concerns, which we call here the welfares firm, what you can see is that, what you can see is that quantitatively, actually, the markup doesn't change much. You can see a little bit here for the really high occupational wage percentiles, there's a little bit of a lower markup, which kind of tells you that we care a little bit less about kind of the distributional impact for these very high wage percentiles. But actually quantitatively it doesn't matter that much. And the reason is, kind of as I was trying to say in the last slide, is that just the occupation and income percentiles in terms of households don't map that well. And so as a result, it's actually curbing AI impact across occupations is not a very good redistributive tool. What about the conservative firm? Again, the conservative firm, they care about preserving wages in a sense. And you can see here exactly, well, they care about preserving wages. And so as a result, first of all, the optimal markup is higher for the conservative firm than for the profit maximizer, because they don't only care about maximizing profits, but also have kind of this intrinsic gain from having higher prices, which induce higher wages. But also you can see kind of this downward sloping here, which is coming from the fact that, well, they care a little bit more if the wage is initially low. And so, of course, then there's a downward sloping coming from the fact that these wages are at the lower end of the occupational wage percentile are lower. And then the final line that I'm showing you here is the multi-objective firm, which is kind of putting it all together. And so you end up with something here quantitatively where the multi-objective firm actually prices AI very similar to profit maximizer for very low income occupations, but then is somewhere much closer to the utilitarian firm that maximizes aggregate efficiency for very high wage percentiles. Now that's on impact. What happens if you look at the long run? Well, in the long run, the important thing to keep in mind here is that in the long run, all these workers that are currently in AI exposed occupations, they will have moved out. And so as a result, there is no kind of distributional impacts anymore to have. And so these parts kind of completely collapse. So then the only thing that really matters is whether the firm cares about aggregate efficiency or not. And so that's what you can see here, where if the firm doesn't care about aggregate efficiency, it charges a higher markup than if it does. What you can also see is that the levels of these markups are increasing. They're increasing because the demand elasticity is declining, because there's less competition from these from the workers that are still in, well, they are not anymore in these occupations because they moved out towards greener pastures. So that kind of tells you that distributional impacts in the short run might give you an incentive to kind of roll out the AI technology slightly less fast by charging a higher markup, but in the long run, you definitely you end up kind of in the same state. Now, something similar happens if AI is extremely productive. I kind of already mentioned it in the theory part. So here, quantitatively, what we're going to consider is the case where the cost savings of AI are actually 80%, not 50%. And so here you can see on the right-hand side that if we do that, then we end up essentially in something that looks like the long run in the baseline case, but on impact. And again, this is coming because these distributional concerns essentially they vanish if the AI technology is really good, because kind of the first order implications of like using this extremely good technology are so much more important in relative terms then. What this also tells you is that, in a sense, kind of the implicit message here is really that these AI firms, they should really worry about distributional impact and labor market stability only if their AIs are so-so. Where the idea of like so-so technologies is that they are barely better than the humans. So they are better, there are slight cost improvements, so firms would adopt them, but they're not that much better. And so we don't gain as much in terms of aggregate efficiency. And so for these so-so technologies, the distributional concerns are gonna matter much more. While if we have a kind of breakthrough, amazing AI technology, then we care less about them. Now, let me make one more comment here before concluding. And that is what we saw here in general is that these distributional impacts didn't really do much in terms of the optimal rollout of AI. They didn't really have a large impact. One of the reasons why that is the case here quantitatively is that, well, we measure these impacts from the Elandou et al. Paper, the task exposure across occupations. And this turns out to be the case that AI technology, as measured through this exposure, is not particularly targeted towards low-income workers. And as a result, any kind of distributional kind of concerns that you would have in the first place are just not that important because the technology doesn't have this slant towards low income. And so the way we show this here is on the left-hand side, we show you the the scatter plot of the share of tasks automatable by AI in a given occupation against the average Pareto weight, so this GH weight in the particular occupation. And you can see that there's essentially no strong correlation here. So that tells you is that like on average, like these AI technologies, they just don't happen to be particularly targeted towards households that we care more about from a wealth perspective, at least like to the degree that we measure this correctly. And then the right-hand side shows you the same idea, but for this kind of disruption costs of the conservative firm. So that's kind of this term that is linked to the initial wage of the household. And I think we see here the same pattern that, again, like these AI technologies don't seem to be particularly targeted towards occupations or households that are particularly earn particularly low wages. I mean, if anything, I think has been said a lot about like maybe radiologists are particularly exposed, and those are certainly not low income. And so essentially that's also what we see in this measure. And as a result, in general, it doesn't look like these AI technologies would be kind of particularly bad from a distributional point of view. And I think that's also something where we think this is really different from the past, where in our paper, Optimal Gradualism, we found something very different when we were looking at the skill bias technological change or the kind of displacement of routine work, where routine work seemed to be very kind of correlated with low income status, while AI doesn't seem to be. So maybe this time around it's different. And that actually brings me kind of towards the end of this presentation. I have two more extensions that I can briefly talk about, but let me just briefly conclude. So what are kind of the key takeaways in our mind here from this paper? So the first one is that in the long run, in general, we think that like what this theory tells us is that socially responsible action, so if the firm cares about it, is to price closer to marginal cost to expand access. So in the sense that it's just like bringing us closer to efficiency. However, in the short run, distributional concerns and stability consideration can call for this more gradual deployment, where in the short run, you might be kind of wanting to charge higher markups than in the long run, because in the short run, you want to kind of reduce the distributional impact. However, these kind of considerations also are going to be less strong if the AI technology is very productive, so it's a great technology, or if the AIs perform tasks that are different from the one that humans do, as we show in one of our extension. And so for these, then the distributional and stability concerns are just not that large relative to the gain from the technology. And so in a sense, what this again says is that like if AI turns out to be amazing technology, maybe we should be less concerned about the distributional concerns. If it's just a so-so technology, then these concerns loom much larger. In the paper, we also have 3 extensions where in the first extension, we look at what if AI performs new tasks or functions. And in that case, kind of quite intuitively, you don't have any of these distributional consequences anymore because, well, you're not competing with any existing human work. And so as a result, then the only trade-off is between profits and access, or profit and total output in a sense, or total aggregate efficiency. And kind of it's much clearer that even in the short run, the kind of social optimal thing to do is expand access. Vice versa, access. In the second extension, we look into the impact of competition among AI firms. So in our baseline setup, we think there's only monopolists. And to be honest, when we started working on this project, that seemed to be a much better assumption than maybe it is right now. And well, what competition is going to do is that it's going to push down prices. So as kind of we expect competition to work in general, which is going to have kind of different, from a social perspective, different effects in the short and long run. In the long run, it's great in terms of increasing aggregate efficiency. Competition is going to kind of help us achieve these goals. But in the short run, it's still going to kind of push towards lower prices. But in the short run, because of our distributional stability concerns, we might actually want to have higher prices. So in the short run, it might actually be then like not helpful to have more competition because it unambiguously leads to lower prices. And then finally, we also in the paper look at kind of non-linearities in the income tax system and kind of show that our model can kind of readily extend to them. Don't think that's kind of, I think the competition and new task point are much more interesting. But yes, so that's the paper. That's kind of all I have to say about the paper. If you have any questions or comments about this, I'm excited to hear them. Thank you so much.
Okay, thanks, Neil, for the very insightful talk. I think we still have a few minutes. Let's open the floor for questions. If there are any questions?
Yes, I can ask a couple of questions. Hi, Niels.
Hello.
This is Long Chen from Luohan Academy. So I enjoyed the paper. Let me ask some questions. So I think this is obviously an interesting question to ask. But firstly, it's not. It kind of propelled me to think about what is a socially minded firm, which qualifies, which does not. But with that question in the background, I'm thinking that let's look at what's happening in reality. I think the first fact is that because of the competition of those large language models, stuff like that, they're being somewhat commoditized. And so it becomes very in a sense, quite inclusive to many, many firms. This is becoming, nobody can dominate, and to really, so that's a fact. I think we know that. The second fact is that, my point is that I think from the purely AI technology point of view, from the infrastructure point of view, it is being inclusive to provide to the firms. I think really what's happening, if we want to think about the social consequence, it's at the application side. It's the firms using the AI tools. It's not really the market dominated bigger players. I think it's more up to the firms at the firm level to decide what to do. And for that brings up the second observation I was thinking while listening to your talk, is that for many firms, they are, I think especially for the so-called socially conscious firms, they are basically, they're not firing many people, but they don't hire people anymore. So they are cautious not to make very dramatic firing decisions, but this replacement thing is going on. I guess put together, I'm trying to think from the practical point of view what's happening here. It is that this is being commoditized in some way, and it's become available to a lot of firms. So what you ask is a good question, but the way firms deal with this, it's really at the firm level, application level. It's not quite at this OpenAI or several other firms. Not quite. So I want to challenge you a little bit to think about this. Secondly, then if it's mostly happening at the firm level, so what are those firms could do? And so I think the probably this is almost like an ESG type of questions. How you think your human employee, your machine employee, or other stuff, and your consumer together, what should they do? So I would like to see your implication. I guess my suggestion is that you probably want to think more about for the social impact. It's about most of the firms, not quite is the AI dominant big market players. How do you think about that angle? The second is that I hope you can provide more constructive recommendations for most of the firms when they have to deal with the AI considerations into their kind of the ESG type of the considerations, or maybe in the US it's not as popular, but we know what it means. Corporate social responsibility. Now, in that sense, then what can I do? So that angle, I think, is less emphasized. I hope it's more.
Great, thank you. Yeah, completely agree with both points. So yeah, I completely agree that nowadays I think that there has been a lot of competition in the AI world, and so maybe kind of thinking about it as pure monopoly is not that useful anymore, because that's not the state anymore. When we started working on this, it seemed to be like a much better assumption, because at that moment in time, it was kind of OpenAI and Anthropic seemed to be like very far ahead of everyone. But papers take some time, and so the world has changed. I agree with that statement. So I think that's why I like the extension to competition that we have in the paper, where kind of I think the insight that's coming from there again is that like competition, we know it drives us towards kind of lower prices, and that can be good in the long run, but maybe not so good in the short run, because in the short run we would like the firm to be able to essentially internalize distributional concerns, which can do less under more competition. Now, in terms of the second point, I completely agree that like in our framework, we don't really in a sense, like we don't really think about AI adoption. We think about really these firms that like kind of push it onto the market. And I think that's a super interesting point that you're making there about like maybe if we are in a world where AI is essentially commoditized, then like the real question that's remaining is not about kind of the supply, because kind of that is as it is, but more like how firms to do. I think that's a very super interesting point, and we don't have much to say about it in this paper, but I think it is a super interesting observation. Yeah, no, I'm very interested in thinking more about this. Thank you.
Right. So as you can see that it's always interesting that people always started to worry about this dominance, but underestimate the computation's role, and we have seen that in the internet in many areas. But that's something interesting point to keep in mind, and also finally, I think because I think finally it's the most important question. To rephrase the question, probably the most meaningful question is the part we just talked about. But I think we can combine with the AI supply side. Basically is the structure of this ability. How it's being provided. It's the competition on the AI providers side, and those tools, the stuff, and how the firms using it together. That what defines the socially responsible firms should do. And that's, I think, I don't know the answer for that, but I think that's very practical and important question. That's important angle to be filled in any case.
Agreed.
Thank you.
Thank you.
Any more questions from the audience? All right, so if there's no more questions, and also our time is up, so let's finally thank Niels for this wonderful talk. And lastly, I want to say Merry Christmas to everybody and Happy New Year. Looking forward to seeing you like in our next event next year.
Thank you so much for having me.
Thank you, Niels. Yeah. Bye-bye.
Thank you. Bye-bye.